Here the forces on this object are acting at an angle from horizontal and vertical directions. You will have to find the components in x and y direction, add the corresponding components, and then find the net force. Here, let's call the first force 100 Newton as F1 and this second force as F2. Now, to find the x component of F1, F1x would be F1, which is 100 times cos of 30 degrees. If you remember the last lecture, I am using cos because the angle 30 degrees is touching the x-axis. This is the x-axis and this is y. So 100 times cos 30 degrees. F1 in the y direction would be 100 times sine 30 degrees. Now let's talk about the signs, the directions. F1 is acting toward the right, and going to the right, x is positive, going to the left, x is negative. Since F1 is going to the right, the x component would be a positive value, and F1 is going downward. Going down, y is negative. So the y component will have a negative value. There will be a minus sign here. For the second one, F2, the x component would be 75 times sine of 40 degrees. And the y component would be 75 times cos of 40 degrees. Now let's talk about the signs. The x component. If you look at the direction of 75 newtons, it's going to the left. It's acting towards the left. And going left, x is negative. So there will be a minus sign. For y, in the y direction, the force is acting downward. And going downward, y is negative. So there will be a minus sign here as well. Now, we will find these values using a calculator. First is 100 times cos 30 degrees. It is 86.6 newtons. Fy would be 100 times sine 30 with a minus sign, so it's minus 50 newtons. Then we have 75 times sine 40 degrees. It's 48.2 newtons with a minus sign. And finally we have 75 times cos 40 degrees. It's 57.45 with a minus sign, and they are all newtons. Now that we have the x and y components, we will find the net x and y. So F net in the x direction would be the first force, x component of the first force, plus x component of the second force. Add them together, 86.6 minus 48.2. And F net y would be the y component of first plus the y component of the second force, minus 50 minus 57.45. Use the calculator. We have 86.6 minus 48.2. It's 38.4 newtons. And then we have minus 50 minus 57.45. It's minus 107.45 newtons. Next, find the net force using this formula. Fx F net in the x square plus F net in the y square and square root of overall. We have 38.4 square plus minus 107.45 square, and then find the square root. Whatever you get in newtons would be the net force acting on this box. To find the direction, the formula is tan inverse the y component of the force divided by the x component of the force, and that gives you the direction of the net force as well. This is the exact steps that you will follow to find the net force. Step 1. Find the x and y component of all the forces. Step 2. Add all the x components to find F net x. Step 3. Find F net y by adding all the y component of all the forces. Step 4. Find the net force using this formula. And step 5, to find the angle, use this formula. And that gives you the net force and the direction on the object. If you understand this, can you find the net force and the direction of the force on this object? You have the given forces, you have the angles, and you have the mass of the object. Write your answers in the comment below.